let's get part 2 finished here. I got lazy after the last one took over an hour to upload. So we're almost done with this question. I think it cut off right around here, actually. So what we have to remind ourselves is we need to do the big radius squared minus the little radius squared, which is going to get us pi times x squared minus x to the fourth. We put that in our integral. We'd already subbed the bounds from 0 to 1, and now it's just going through and doing some antiderivatives here. This pi can come out front, that's unaltered. We take the antiderivative here. And that's from 0 to 1. 1 is really nice to plug in, so is 0 here. So it's pi times 1/3 minus 1/5. So common denominators there. We're going to get, what is this? 5/15 minus 3/15. 2 pi over 15 is looking like our final answer here. And keep in mind that is the volume of this area, or the volume of this object as we spin it around here. And remember, this one is a washer because it has that gap in between. Let's do another washer and see how these questions can progress as well. So we're using the same two enclosures, y equals x squared and y equals x. So we're going to have that same shape, except now we're rotating this about the line y equals 2, and we want to find the volume. So let's get this figure drawn. Looks like the same little sliver that we have here. And now we're rotating this around the line y equals 2. So that means we're going to have something up here that's the same shape. And we're spinning this around so that they create one solid piece of object. The ends, it's just going to be a circle, but what's really important is looking at some cross section in the middle. And if we look at some cross section in the middle, notice there is this gap still. So this is yet again going to be another case where this is a washer that we're looking at. And I think it's a lot easier to understand these if you label everything along the way. The dead middle of what we're rotating around is 2. The next kind of circle that we hit if we're going out, it's easier to look down here, is that straight line. So that's going to be, what, x? And then the next one we're going to hit is x squared. So we're now trying to find our little r and our big R here. And remember, that's going to be subtracting these two. The order you subtract them in doesn't actually matter. I typically, it really doesn't matter. I like the number if I can have it first and have it not be negative. And I'll explain to you why it doesn't matter the order that we're going in just a second. So our area here is pi big R squared minus pi little r squared. We can factor out the pi though. So the big R here is 2 minus x squared. We have to square all of that, minus 2 minus x squared. And that's what we would have here. And to answer that question of why it doesn't matter which order we have it in, let's just pick the small radius. 2 minus x squared is going to be the same thing as x minus 2 squared. And I'll show that quickly. So we'd have to actually FOIL these out with one another, distribute them. So we get 4 minus 4x plus x squared here. Over here we get x squared minus 4x plus 4. Notice they're the same thing, so the order doesn't matter. in which you subtract them, because once you square them, it makes everything going to be the same. So we have this as our overall area here. What might be nice to do here, kind of in our side work, is to actually square these out and see what we're going to get to make our integral have a little less mess to it. So we have 4 minus 4x squared here, plus x to the 4th minus. And we did this one out over here. 4 minus 4x plus x squared. Now remember, we have to properly kind of subtract these things, distribute that negative. The 4 minus 4, those aren't going to be there anymore. The minus 4x is nothing to factor with, so we have a minus 4x here. We are subtracting an x squared, so minus 5x squared plus x to the 4th. And I think I've done that right. Nope, this negative, I'm subtracting it, whoops. That's why I'm double checking here. So that's a positive 4x. Okay, we have everything here, so we can start thinking about our volume, which we're actually solving things for. So we've found our area here. I think a lot of people like looking at it with the largest exponent first, so I'll do that. It does not matter. I guess it should be said that it is with respect to x that we're doing all of this with, because although we're not rotating around the x-axis, we're rotating around something parallel to the x-axis. So that's going to tell us it's with respect to x, which is good since we set up our area to be something with respect to x. And now we need the bounds. So from where to where are we covering this on our bounds? And that is from 0 to 1 still, because they intersect at the point 0, 0 still, and 1, 1. At this point, let's actually take the antiderivative. Pi comes out front. 1/5 x to the 5th minus 5/3 x to the 3rd plus 2x squared from 0 to 1. So just normal antiderivative of each one of these pieces. Let's put the 1 in, because what the 0 is going to make it just 0 at the end. So we have 1/5 minus 5/3 plus 2. I don't want to get all these common denominators first. I know that 2 minus 5/3 is going to be 1/3. I think so. So 1/5 plus 1/3. So we have 3/15 plus 5/15. 8 pi over 15 is what we're looking at for our final answer here. Yet again, that is the volume of this shape as we have rotated around the line y equals 2. Okay, I know this might be a little confusing. Take your time, rewatch through this if you're a little confused. The book works right along with it too. The book actually has better pictures than I can draw here, if you'd like to see this in 6.2. And there's one more example I want us to go through here in this section. And yet again, it's dealing with these same two, y equals x squared and y equals x. So y equals x squared. We get that crescent shape that we've seen so often. That's where they intersect. This time we're rotating about the line x equals -1. Notice this is the first time in these last couple questions we're rotating around a vertical line. That should be a big indicator of when we're setting up our equation here, that this is with respect to y, since it's a line that's parallel to the y-axis. That should be something that you're just noticing right away, whether you're rotating around a vertical or a horizontal line. Okay, so now I'm thinking, okay, we're going over here. And if we're looking at this kind of cross section, if we chopped it this way, we still have this washer motion that we're looking at. So there is that hole in it. So I think that's really good to draw our picture here, help us identify kind of what we're looking at. And then let's label everything. That middle point here is a -1. The first thing that we hit as we're going out from that, you might think is x right away, because that's what we've been using. But keep in mind, we're now with respect to y. So instead of x, this is actually y that we have here. And here it's y equals x squared, but we want to solve this in terms of y. So that is actually x equals the square root of y. So let me talk that through once more. So here we would normally have y equals x squared, but in solving for y, it's going to be the square root of y. And this one we just had y equals x, so that is y. And the middle was -1. So these are the three numbers that we're looking at when trying to set up our big R and little r. Little r here, you can have -1 minus y. I personally like y minus -1 because we get everything to be in the positive realm, right? Y minus -1 because you're subtracting these guys. Same thing over here when we're setting up our big R. I like the square root of y plus 1. That way we're not dealing with any negatives. Life is a lot simpler than trying to go through and do it the other way. -1 minus y or -1 minus square root of y. Let's find out the exact area of this thing. Yet again, area is pi big R squared minus little r squared. If you're still confused, that's because we're looking for this washer part. So it's this part in red. So that's why we have to do that subtraction. Big R squared here, square root of y plus 1. And this is a minus, and we need y plus 1. Remember, we have to distribute here. This first term does not just become y plus 1. After you square that all out, we have to actually do our distribution and everything here. So it's y plus 2 square root of y plus 1. And then minus, we have y squared plus 2y plus 1. Let's subtract terms. I can see that the 1s are going to subtract away. That's nice. Y minus 2y we're going to get. So we will have a -y here, and then a minus y squared there. And as I've said before, some people really are particular about the ordering. I don't care. It doesn't matter to me. They like to go from largest to smallest. If you want to do that, that's our order there. Sorry if you couldn't see that below. The only thing left is to figure out what are the bounds here. Remember, we're with respect to y. What's the smallest y value initially? It's still 0 because they cross at 0, 0. And then the largest was 1, 1. So that largest y value there is 1. Don't get confused and going off in the other shape. Just always stick with that initial 1. That's always going to get you there. Okay. Let's do some antiderivative stuff here. -1/3 y to the third minus 1/2 y squared plus, okay, this is going to become y to the 3/2, which gets us 4/3 here. I think I did that right. And here we're from 0 to 1. Great. I haven't made any mistakes yet. At this point, 1 and 0, the zeros go away. That's really nice. So -1/3 minus 1/2 plus 4/3. We can see -1/3, that gets us 1 here. 1 minus 1/2 is 1/2. So pi/2 is the volume that we're looking for here. Great. Okay, so we finished up this section. This homework will take you a little bit. I think I might also post this week just to kind of help push us through 6.5. That's a really quick section. So maybe I'll post that tomorrow. And I'll say let's have these due by Monday. The homework I'll post in the description in the comments section. It's the same ones that I gave you way back in March. And I guess the last thing is if we'd be interested in like a homework Zoom session to make things better or not. So I'll post that question in the comments section as well, the description. Okay. See you later, guys.